Hello everyone, this is Sachin Shinge. Today we are going to discuss Csirnet 2020 question. Okay, part C, organic chemistry. So find the major product of the following reaction. So this is our substrate, and this is our reagent. This is our reagent and reaction condition. So what is the reagent? Reagent is a base. Base and very strong base. Very strong base. Okay, sodium ethoxide. Okay, so this is intramolecular aldol condensation reaction. Intramolecular aldol condensation, intramolecular aldol condensation reaction. Okay, so there are four options provided: option A, option B, option C, and D. We need to find out the major product of this particular reaction. So let us discuss the major product of this particular reaction. So I will take new slide. Let us discuss the mechanism of this particular reaction. So what is the substrate? Substrate is this. Substrate is this. This is our substrate. Okay, this is our substrate. These are the lone pair of this particular oxygen. So this is intramolecular aldol condensation. Okay, intramolecular aldol condensation. So base is a sodium ethoxide. Base is a sodium ethoxide. So here in this substrate, how many alpha hydrogens are present? How many alpha sites are present? And that alpha site, whether it is having alpha hydrogens, so there are how many alpha sites are present? So this is the alpha carbon, this is alpha carbon, this is alpha carbon as compared to this carbonyl compound. As compared to this carbonyl, this is alpha carbon, and this is alpha carbon. As compared to this carbonyl, this is alpha carbon, and this is alpha carbon. Okay, so as compared to this carbonyl, this carbonyl, this is alpha carbon, and this alpha carbon having one hydrogen. This is also alpha carbon having one hydrogen. This is alpha. This is also as compared to this carbonyl. This is alpha carbon, and this is also alpha carbon, and this alpha carbon having hydrogen, and this alpha carbon having one hydrogen. And alpha hydrogens are more acidic in nature. You know it very well. So problem is that. So here problem is there. Problem is that when we provide this particular sodium ethoxide, when we provide this sodium ethoxide, then this base will take proton from which side? This is the big question. Okay, so let's try. If this base abstract, so this is number 1, let us suppose this is carbon number 1, 2, 3, 4, 5, 6, 7. Okay, so when we provide base, if this base abstract proton from this side, then there is a formation of enolate like this. There is a formation of double bond over here, and at the same time this bond has to break, because this bond has to break like this. This bond will open up like this. You know it very well. And there is a formation of this particular product. Sodium will come over here. You know it very well. And here carbonyl is present. So here this enolate will generate. Okay, here formation of this particular enolate takes place. Enolate ion takes place. Okay. So when these enolates are generally unstable. When this enolate come back like this, when this anion come back like this, there is a when this anion when come back, this pi bond will break and this pi bond is going to attack on this carbon system or this carbon system like this. So if it attacks on this carbonyl compound, if this carbonyl site, then there is a possibility of first carbon, second carbon, third carbon, fourth carbon and fifth carbon. There is a possibility of 5-membered ring. First, second, third, fourth and fifth. 5-membered ring. And if it attacks on this carbonyl site, then there is a possibility of 6-membered ring. So which is more stable? Which is more stable? That we need to understand. So before that, when this proton abstract, there is a possibility of two types. There is a possibility of attacks. After formation of enolate, there is a possibility of two types. There is a possibility of two types of attacks possible. First attack and second attack. If it is attack on the first carbonyl, then there is a possibility of formation of 5-membered ring. And if it attacks on this particular carbonyl system, then there is a possibility of 6-membered ring. Before that, if you abstract proton from this site, then there is a possibility of first carbon, second carbon, third carbon. So there is a possibility of 3-membered ring. 3-membered ring. And 3-membered ring is highly unstable. Highly unstable. Okay. Highly unstable. If it abstract proton from this side, then there is a possibility of two types. There is a possibility of this carbonyl site attack may takes place on this carbonyl site or this carbonyl site. Okay. So both are symmetrical in nature. So out of two carbonyl, attack will take place on one carbon. Okay. So if it attacks from this carbon, then there is a possibility of 1, second, third. So again there is a possibility of 3-membered ring, which is highly unstable. And if it takes proton from this side, then there is a possibility of first carbon, second carbon, third carbon, fourth carbon, first, second, third, fourth, fifth carbon. Again there is a possibility of 5-membered ring. 5-membered ring. 5-membered rings are generally stable. Generally stable. Okay, 5-membered rings are generally stable one. Okay. But the problem is there that if there is a possibility, if formation of 5-membered ring, if the 5-membered ring generated over there, then after abstracting this particular proton, it will leave out from the reaction and there is a formation of double bond over here. And in the 5-membered ring, this is sp2 center and sp2 center, this is sp2 center, and this is also two sp2 centers. That means this ring is having angle strain. And in this angle strain, again you are generating one double bond system. Again we are increasing angle strain. That means this ring becomes highly unstable in nature. So this 5-membered ring will not generate. We need to go to the 6-membered ring. 6-membered ring. Okay. So we need to form 6-membered ring. Then and then only we will get our appropriate and major product. So this is unstable as compared to the 6-membered ring. Okay. So let us discuss that mechanism now. So let us discuss the mechanism. Let us discuss the mechanism. So what is our substrate? This is our substrate. Okay. So we need to take this particular proton or we need to take this particular proton. So both are symmetrical in nature. You can take from this side or this side. You can abstract from this side. This is also alpha and this is also alpha. Okay. So when we provide sodium ethoxide, to this particular substrate, what is going to happen? This base will take proton from this side only, and there is a formation of enolate anion. Okay, this sigma bond will break. There is a formation of anion system over here, and this anion, when do the conjugation, this pi bond has to break, and this pi bond will come over here on the oxygen. So this is our concept. Okay, so there is a formation of enolate anion like this. There is a formation of enolate anion like this. There is a formation of enolate anion like this. Okay, there is a formation of enolate anion like this. Here double bond O is that. Again it is enolates are unstable in nature. Enolates are unstable in nature. So this is intramolecular aldol condensation. So reaction will take place within the substrate. So it will come back like this, and this pi bond will break, and it is going to attack on this particular carbon, and it was going to open like this. Okay, when it attacks, it has to break old pi bond. And when it attacks on this particular carbonyl system, there is the opening of this bond takes place like this. This is our concept. Okay. So how many carbons involved in this particular substrate? So this is first carbon, this is second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon. That means six membered ring is generated over here. So I will write six membered ring. So this is first, second, third, fourth, fifth, and sixth carbon. Okay. So first carbon, second carbon having double bond, third carbon having nothing, fourth carbon having one carbonyl group, and fifth carbon having nothing, sixth carbon having this. Okay, attack taken place on this sixth carbon. Okay, so there is here bond oxygen minus methyl system is present over here. So this is our substrate. Okay, this is our substrate. So when it taken proton from this particular alpha site of this particular substrate, then there is a generation of ethanol. ethanol. So ethanol is generated in the system. So ethanol is present. ethanol is generated. Ethanol is present in the substrate. So it will take. So whatever the anion. So anions are generally unstable. So this anion not at all stable in nature. You know it very well. Charge structures are always unstable. So it will take proton, simply proton from this particular ethanol molecule. So it will take proton from this ethanol molecule. So this is proton. It will take proton, and there is a generation of again ETO minus like this. So after taking proton, after abstracting the proton, there is a formation of this particular compound, like this. And when we add in the presence of base, that is sodium ethoxide, what will happen? Sodium ethoxide. So base is sodium ethoxide. Base is sodium ethoxide OET minus. Okay. So there are two hydrogens again. There are two hydrogens here, here, and here. There are two possibilities. So base will abstract proton from the more acidic in nature. So as compared to this alpha carbon and this alpha carbon, this is also alpha carbon. This hydroxyl group. If I consider this is the functional, if it is a functional group, then this carbon is alpha carbon. Okay. If I consider this is the functional group, then this carbon is beta carbon. Okay. So base will abstract from that side which is having more acidic proton. Okay. So base will take proton from this side, and simultaneously this will come back here and it will leave out from the reaction, and there is a formation of double bond over here like this. This is a double bond system, and this is our methyl system. This is our methyl system. This is our methyl system. Okay, so one ketone group is present over here. So base abstracted from this type of. Now this is our final product. So this is our final product. So this is our major product. This is our major product. So this is our final product of this particular reaction. So this is intramolecular aldol condensation, intramolecular aldol condensation. So what is the major product? So this is our major product. So this is our major product. Okay, so this is our major product. This is our major product. Okay, this is our major product and final product of this particular reaction. Major product. This is our major product. Thank you very much for watching the video. Please do like, share, subscribe to my channel and watch my lectures in the incoming days. Thank you very much. Thank you.